Bom, eu tenho alguns anúncios só para fazer, para que a nossa transmissão online começou no meio da palestra do Nick. Então, eu vou dar um recado para quem está assistindo a gente pela internet. Eu estou recebendo já os e-mails de quem está assistindo. Então, quem estiver assistindo a gente online, pode mandar suas perguntas para o meu e-mail que vocês têm. Mas quem não souber é paulofc@usp.br. Vou repetir, Paulo, F de faca, C de casa, @usp.br. Ou você manda mensagem de texto para o meu celular, que é o 11 9500 3766. 11, São Paulo, 9500 37, eu não preciso de outro microfone, 66. Então agora nós estamos oficialmente online e eu vou switch again to English. I would like to introduce our next presenter is Ulrich Lohbauer from the University of Erlangen in Germany. Thank you very much for coming, Ulrich. It's a pleasure to have you here. Now we have to switch this to the presentation mode. Is your microphone working?
Everybody understands what I'm saying? Yes, I think so. Paula, thanks a lot for the introduction and for inviting me here to this very great audience. It's an honor for me to speak for you. I would do it the same way. I'd like to introduce me, myself, my place, where I'm coming from, in order to then go to the scientific part. I'm coming from Germany. In Europe and in Germany, we are from the southeast part. This is Bavaria. In Bavaria, there are two main cities. This is Munich, and at this point, I do not want to talk about soccer and Manchester City, because we recently had a game. And the second one in the north is Nuremberg, and these two, and this is very close, Nuremberg, Fürth, Erlangen, this is very close. This is a growing center where I'm coming from. Nuremberg is a city of the medieval ages. It's very old it's a very old city in Germany, and it's famous for their castle, for their old historic town, and is also, let's say, not famous but well known for a history which is recently, 60 years ago, there was a guy in Germany who had some ideas about the world and the regulation, and he somehow decided that Nuremberg should be a capital for him, and he left a lot of buildings in our city a little bit outside, where we now put the football stadium, where we put the ice hockey stadium, and so on. So we used the buildings there. But actually it's famous for their Christmas market in December. It's very nice. It's a very famous market with a lot of people coming to Nuremberg for the specialties at the time. Further, we do have, because I'm in Brazil and there's so much exotic and nice food, so I need to somehow tell you what we have. At least some sausages, where a big American company used the sausages and they very locally created a Nürnberger. This is a, I don't know if you have it in the US, I think it's very local in Bavaria. And of course, our region is very famous for the variety of beers, and especially our city, you see it here, that has the highest brewery density all over the world. So it's a very funny thing. You can spend a weekend without boring things. Actually, if you go out of the cities, there is a lot of landscape, which is also characterized from the medieval times, you see here. And also Erlangen as a city has a lot of old buildings, renovated buildings. And this one especially is the castle of Erlangen, where is the administration of our university located. It's, I think, everywhere in the world it's the same. The administration has the nicest buildings. And this is the garden of the castle, and not that nice, but quite nice. It's our dental clinic, the two buildings there. And we, as a lab section, we are located in the 4th floor. So at least we do have the view on the nice buildings. This is our team, our lab there. This is a picture 1 year ago. So it changes year by year, but we are a group of 10 to 15 people working in dental materials. So we work on ceramics as well as on resin composites. And when I went through the program for today, there are so many experts talking about ceramics, so I decided I would like to stay with resin composites in order to balance the whole thing. So I entitled the presentation today, Lifetime of Restorative Materials, in the focus of mechanical fatigue. This is the fatiguing part now. So everybody knows from daily life, we do have failure, we do have fractures. We see this bicycle here. I hope nobody made the experience with this kind of fracture. You can also see the pedals of a bicycle where you have a fatigue fracture by pulling the pedals in a cyclic way. You see, this is somehow similar to dentistry. You get a pattern, a fatigue pattern, and the failure after years of service. Some more dramatic things. Some might remember an accident from the Hawaiian airline back in 1988, where the airplane lost the roof due to a fatigue failure. And in Germany there was an accident in 1998 with a big train accident where the reason they found in the wheels, and these wheels here, they got the micro cracks in the wheel and they failed. The wheels failed and got this accident. Well, in dentistry I think it's not that dramatic if a restoration fails. But anyway, the principles are somehow the same, and the mechanisms can be transferred also to dentistry. So I'd like to give you an idea what we are doing in our lab, what is our thinking about the lifetime and the fatigue of resin composites in this case. So I would like to start with a clinical outline of what is known about fatigue and fracture. Then the fatigue approach itself, cyclic fatigue I mentioned, the related mechanisms, why do these materials degrade. Then some fractographic observations, but only some. There is another presentation in the afternoon which tells you far more about fractography as I can do. And then coming back to the clinical situations with some conclusions and relevance of fatigue measurements. Nick did this in his presentation, so I will do the same. That the materials, the resin composites you can buy today on the market, they are so subdivided that you need to specify a resin composite for a certain application. So it's necessary to subdivide the properties as well for anterior, for example, as for posterior composites. And then you further need to subdivide if you look at short-term properties in contrast to long-term properties. I will not talk about short-term. This was, Nick told us a lot about short-term properties. Well, in the anterior region, the aesthetics are very important. In the long term, we do have some properties. Well, let's say the thermal expansion is a very important property in the anterior region, and which is not that important in the posterior region. But in contrast, we also have in the posterior region some short-term and long-term properties. And if you look at that, there are all these properties like fatigue, crack growth, toughness, wear, degradation by hydrolysis, the hardness of material, creep, whatever can happen to degrade a material. This is especially important because it's in the load-bearing area, the posterior area, and we need to focus on these properties if we would like to talk about lifetime of restoration. So, what do we know from the clinical side, from controlled clinical studies? If you go to the literature, there are so many studies about failure, lifetime success of restorative materials, and for resin composites, to mention that in the beginning, it's very difficult because it has a short history, the resin composites, and if you read now data, let's say 11, 12 years of success, then the material at least is 15 years old, and like that. So you see there a lot of changes have been made the last 15, 20 years, so it's a little bit, you need to be a little bit skeptic. So, but there is a nice and comprehensive review they did on comparing indirect with direct materials in the posterior region. And they summed it up, giving us some indication about annual failure rates of materials or placement techniques. And there is the direct resin composite, which is not that bad compared to indirect restorations. But for this graph, I would like to say it's, again, you need to be skeptic because the experience on resin composites is about 10, 20, 25 years. And there is a different experience on amalgam or gold inlay and onlay restoration, which lasts far longer. So you need to be skeptic with these numbers here. But anyway, this review also tells us that the reasons for failure, next to secondary carriers, which is coming from polymeric shrinkage and toughness, and then also fracture is mentioned, marginal defects, wear, so mechanical properties of the material itself, and sensitivities as main reasons for failure. And further, they also subdivided, or they distinguished between early failures after placement and fatigue-related failures after years of service. If we go to specific studies, there are really important clinical studies made in the Netherlands, and they, for example, they stated the reasons for failure after 5 years. You see here the secondary carriers, and you see the restoration fracture with 17% and so on. But I'd like to point out that the fracture of the restoration is a main failure criteria. They recently published a different paper where they reduced the number of failures due to fracture, but it's a question about the placement technique. So you see there's a huge learning curve within the last 20 years about resin composites, and the materials you have today and the adhesive techniques you have today is not comparable with the materials they used in their studies 20 years ago. So for example, in 2000 they published 11 years data, so this composite must be at least 25 years old. But anyhow, they found again the failures, composite failures, composite fractures as a main reason for failure clinically. And so we tried to find out what are the failures, how do they look like, how can we somehow predict the failure in the lab before they come to the clinical situation. A failure could look like that, marginal defect, or bulk fracture, or chipping fractures from the occlusal side.